So when I look at this problem, I notice that I don't have opposites to begin with. But if I multiply the first equation by 2, this is going to become a positive 8x. So the first equation now becomes positive 8x plus 6y equals positive 24. An interesting thing happens though. When I combine my equations, this whole side becomes 0 because everything there, all my coefficients are opposites. When I add them together, I get 0. So this side is 0, and 20 and 24 is 44. So my variables are both gone, and I get this statement that's impossible. 0 cannot equal 44. So this is a no solution problem. If I graphed these lines, it turns out that they're parallel and they never intersect, because the solutions that we find are the point of intersection of the lines. Now the second equation, I'm just going to set this one up. If you've watched enough of part 1 and watched this, then once you get the setup done, the rest of it's not as bad. I don't have opposites yet. Hang on just a second. So I look and I say, well, 3 and 5 both go into 15, or, looking at my y coefficients, 2 and 5 both go into 10. I'm going to deal with the ones that are smaller numbers, the 2 and 5 instead of the 3 and 5. If I multiply the first equation by 5, this would make this a minus 10y. If that's the case, then I want the second one to be a plus 10y, so I would multiply it by negative 2. What that's going to give me for these equations is 15x minus 10y equals 10, and negative 10x plus 10y equals negative 20. Now by the time I solve this, I end up with 5x equals negative 10, so x equals negative 2. And you would need to show all of this work. And by the time I substitute negative 2 in, I end up with y is negative 4. The next equation, again, I don't have opposites. 4 doesn't go into 10, 2 doesn't go into 7, but if I multiply the first equation by 5, this will make this a minus 20x. So then I multiply the second equation by negative 2, and that'll make that one a plus 20x. So then I'll have the opposites that I can add together to eliminate, in this case, my x variable. So I end up with negative 20x minus 10y equals 70. And the second equation, multiplying everything by negative 2, becomes positive 20x minus 14y equals positive 50. So I end up with, when I combine them, negative 24y equals 120, and then I solve and I get y equals negative 5. So y is negative 5. I need to go find my x. When I do that, I end up with, y is negative 5. I go find my x, and when I go find my x, I realize that y is, let me see, I have to think about this. This would make this a plus 10, so 4y, or x is negative 1, if that makes sense. Then 10, yep, x is negative 1, y is negative 5. Now, in this one, again, I don't have opposites, but I can create them. And I'm realizing I just put the same problem down twice, so we're going to skip that one. Here I have, boy, if I just multiplied this by 2, it would make it a negative 8x that I could add to this positive 8x to eliminate x. So negative 8x plus 16y equals positive 24. Now this is similar to a couple problems ago in that when I combine this whole side is 0. But what happens on this side, negative 24 and positive 24, is also 0. So instead of getting some sort of gibberish thing like 0 equals 44, which is never true, I get 0 equals 0, which is always true. So this one, if I graphed those, it turns out they're the same line. So there are infinitely many solutions, because if you graph one line on top of another, they have an infinite number of points of intersection. And that is part 2.